Thank you everyone for attending. We thought we would open today's technical overview of our BCD REVOLV solution with a quick recap of what we did last time. So what we're hoping to do today is give everyone an opportunity to have a much more technical overview of the different products in the REVOLV line, understand why we chose a hybrid, hyper-converged infrastructure, and like I said, give everyone a chance to ask questions and get answers to their satisfaction, which is why Darren and Josh are both here. So as you may remember, the last time we were together with, I hope most of you, which would have been last Thursday, we went over our different versions of REVOLV, the different products in the line. So I'll just very quickly touch on those. DeepStore Lite, which is a 3-node, 1-SAN solution that has both a bandwidth cap and a total storage cap. The DeepStore Lite is really designed for smaller HHCI installs or situations where a potential customer is not quite ready to go whole hog on an HHCI solution. You have the DeepStore, which is our standard HHCI product, 4 nodes in the compute cluster, 1 storage device, and then an expansion that will go all the way to a total of 4 petabytes. This is the one that has a throughput, a sustained throughput of 2,500 megabits per second. Comes obviously with node failover. This is, as I said, sort of the standard version. Then we have the DeepStore Plus, which is differentiated simply by the fact that you have 2 SANs versus 1. The point of 2 SANs being the ability to lose an entire storage SAN and not lose any data. So effectively, you are writing simultaneously to both SANs to create a physical copy and backup versus just having it covered by a RAID 6 style solution. So Darren, let's move to our presenters. We'll spend no time. Oh, I'm sorry, I forgot about the powerful partners. My fault, Dell and VMware. So one thing that's important to remember, and this was also in the last session, was that BCD and our leadership made a very, very smart decision, a very careful decision to work with both Dell and VMware. Not only is VMware and Dell is obviously Dell, but the ability to work with them has also given us the ability to maintain the absolute highest level of support for the product, whether or not BCD is capable of solving the problem, involved in the problem, or even, frankly, around to solve the problem. Dell servers and storage on the SAN side is what we use. Obviously, VMware is the other side. And again, this means that no matter what, we all know that support will be available for the product. We have not created our own hypervisor. We have not purchased gray market hardware. We have gone this route to bring the absolute top of the line to the customer, and yet have not carried a top of the line price. So let me tell you a little bit about Darren. We certainly don't need to know anything about me, and sadly that picture of me is obviously quite a bit old. So Darren has had over 20 years in the IT space, which specializing in high availability systems design, infrastructure, critical infrastructure. He's expert level certified with Cisco, HP, Juniper, and Microsoft. He was the lead network architect over at Pelco for 9 years. Then he was with Avaya for 4 years, running some switching architecture infrastructure, focusing on physical security. And now he runs all of our network services and heads up our advanced systems architecture team. So with that, I'm going to turn it over to someone that might be close to the smartest person I know. Josh, you're up there too. And Darren, why don't you give us a little bit of a technical overview on our new REVOLV product line?
Scott, thank you. I really wanted to touch on something before we move forward. That this has truly been a collaborative team effort. As we put this particular product together, there was a lot of input from both Dell and from VMware, and really helped us reach what I view as the optimal solution for we feel for the target market. So for the agenda today, we obviously have already covered the team introductions. We are going to we're going to talk about a conceptual overview of the REVOLV HCI model or hybrid HCI model. talk a little bit about, how did we get here? It's been about 2 years now that my team has been working and evaluating different options in hyperconvergence. And there are a lot of factors that really led us down this road that we'll talk about. But at the end of the day, the solution that we put forward not only has to make sense from a technical perspective, but it has to solve the business needs for both the integrator and the customer itself. And there was a lot of trials and tribulations we went through to come to the right conclusion. But it's kind of how we got where we're at today. We're going to do a review or an overview of the REVOLV architectural model. And in that review of the architectural model, we're going to talk about what the concepts are associated with a hybrid hyperconverged model versus a traditional hyperconverged model. We're going to talk about the benefits associated with the architecture. What are the overall benefits of going with a hybrid HCI as opposed to a traditional HCI model? We're going to talk about not only that, but what are the benefits to the end user and the customer and the integrator with respects to price comparison to what we'd see with traditional HCI, and do an analysis of some of the weaknesses we found as we looked at traditional HCI. And we're going to move over and we're going to do a technical deep dive into the architecture that comprises REVOLV itself. What are the components of the pure HCI portion? Because there are a couple different aspects of this. There's a portion in the hybrid that runs in a pure HCI environment. And depending upon the actual VMS platform you're using, you may wind up with a solution that actually does pure HCI for a tier 1 storage, or you may wind up with a solution that leverages the HCI and the SSD high-speed storage literally for the operating system and the databases where necessary, while leveraging traditional storage in the back end. So we'll look at that and what portions are HCI. We'll look at the high availability design aspect, not only from a vSAN perspective in VMware, leveraging vMotion, but we'll also talk about how we built high availability into both the virtualized network aspects, how we segmented the traffic, and how we created high availability on the actual back-end infrastructure on the network as well. And then finally, we'll talk about the overall infrastructure design. And then we'll move on and we'll do a quick REVOLV platform demonstration. I'll give you kind of a kick the tires experience where we go in and we actually open up vCenter, take a look at what we currently have today on the system under test, talk a little bit about the bitrate and metrics we have running through it, and do a traditional vMotion transfer or a simulated failure or a movement of a virtual machine. And then following that, we're going to go ahead and we're going to open it up for questions at that point in time. So if we look at benefits of a hyperconvergence for physical security applications, this was always a big one for me, because coming from the IT side of the market with Avaya at one point, there's always the buzzwords that get thrown out there. And in the IT side of the market, the buzzword for a long time was software-defined networking. And I remember going to several trade shows and asking vendors what software-defined networking meant. And if I asked 10 different vendors, I got 10 different answers. Hyperconverged infrastructure really isn't in the same boat as that today, but it definitely is a buzzword. It's coming down the road, and it's things that we're going to see escalating its use in the next 1 to 3 years, because there's some major advantages to it. And the number one thing on the first thing you see is VM mobility. Today, if you take a look at different VMS platforms or different architectures out there, you have some companies that do really well with providing failover scenarios where you can record to a secondary archive server, or you can fail services over in the event that an archive or a server or a virtual machine were to go offline. But VM mobility gives you the ability to actually transfer those services from one particular physical piece of hardware to another. And when doing that, you get a lot of benefits to it. There are a lot of access control vendors out there that really don't do failover well. And I'm sure there's other aspects or other technologies out there, but any technology where you don't have a good failover or migration strategy in the event of failure, HCI can bring a solution to the market that will retain your functionality in the event that you have a node failure. It brings the point that it's a great option to have the VM mobility or the ability to move the actual function of the machine in those particular implementations where there's little to no monitoring or response capabilities.
Hey,
I
Derek,
did
don't be afraid to take a drink of water if you need to.
thanks. I did some implementation for some remote water districts and implementations for some casinos where they simply didn't have a lot of staff there to respond 24 hours a day that could actively bring something online. But when you have this virtual environment, this hyperconvergence environment, it happens in an automated fashion. Most important, and the second note there, you retain your data. And this is huge in the fact that there are a lot of software out there that will allow you to fail the services over or record your cameras to a secondary archiver or a third or tertiary archiver in the event that you have failure. The main problem is you don't have access to the data that you had on the box that actually failed. When you look at a hyper-converged environment, a hyper-converged environment maintains that by wide striping over erasure coding across the clusters or node, as opposed to array level at a box. So if you have 3 or 4 nodes in a cluster and one node fails, the vMotion will actually move the virtual machine over to a subsequent node and bring it online. But the real important thing is you don't lose your retention of data. All the data that was recorded, all the data that was available to the archiver immediately becomes available to the archiver again. And if there's software supported failover features as well as that, you can actually reduce your outage time by using software failover mechanisms kind of in the interim. So by distributing all the resources across more than one node and making it tolerant to node failure, it makes it a perfect fit for mission critical applications. When we talk about distributed resources or sharing resources, this is one that I always kind of put this and the next bullet point there, a more efficient use of resources hand in hand. Today, on average, if you look at an average archiver on a server, you're going to hover somewhere between 40 to 60% of the CPU utilization, and you might find yourself somewhere between 20 to 60% of the memory utilization on the box, depending on how it's specified. So my question to everybody is, what happens to the rest of those resources? Well, they do nothing. If you're not in a virtualized environment where you can effectively share resources between machines in a cluster, what winds up happening is you don't utilize those resources. A more efficient utilization of that would be to take the wasted resources and either apply them to other particular virtual machines in that project, or even use that to apply to access control or alarms or some other types of technology that don't really require a large amount of storage and typically require a minimal amount of CPU. So in today's world, we're really just kind of wasting those resources on physical boxes. So here in the model, the first we're going to look at is traditional HCI. So when you look at a traditional HCI approach, it's always a two-tiered model with hyperconverged. The first tier is always going to be solid state fast storage. And the second tier, typically to bring the cost down, is going to be rotational drives that obviously have a lower throughput and a lower handling capacity, but decrease the overall cost of the project by leveraging that 2 tiers of storage. So in essence, the vSAN SSD here shown in the diagram becomes your caching tier, and the secondary becomes your rotational tier. So what we found through about our almost 2 years of testing is when you start to get to high bit rates and you start to get to some of the most mission critical applications that are of any size with respects to and its scale out capabilities, we found that to maintain the vendor standard, you almost always had to go to an all flash or an all SSD operation to maintain the failure state. What winds up happening is when you have 3 or 4 nodes and you fail one node, when you involve rotational drives, you've reduced your rotational spindle count and you reduced your capability to handle that ingress data coming in. To offset that, in most cases, you have to move over to an all SSD or an all flash tier. The problem with that is it's not typically cost competitive to do that. If you price out a project that has to go out to a petabyte in storage and you're looking at a traditional HCI approach, it can get quite costly if you have a higher bit rate coming in, and during a node failure, you're not going to be able to keep up with the data throughput that's coming into the actual cluster or the VM for recording. So what we found is that more often than not, in order to meet the criteria and pass the criteria for testing with the VMS vendors, we almost always had to go to an all SSD operation or an all flash tier within the box. And while it actually has you set it up in 2 tiers, everything's running off of high-speed devices or solid-state machines, or solid-state devices themselves. The last note on here is about compute and storage resources. This is kind of the biggest problem I have with traditional HCI. They're bound together. And through 2 years of testing various vendors at various bit rates coming through here, one thing I found to be true every time: the resources are not depleted at the same rate. Your retention is going to be depleted, or your storage is going to be depleted well before your CPU and memory are depleted. So in a traditional HCI model, the idea is with every box you add compute and you add storage. Well, the problem with that is, what if you don't need more compute resources? What if you have plenty of compute resources? What if you have 60 virtual CPUs left on a gold processor across a machine, yet you've run out of storage? You're continually going to be adding boxes to this HCI model that's going to increase not only your CPU and your storage capacity and your memory capacity, but it's going to be doing it in such a fashion that you increase the CPU and compute side when you really don't need to. This led us to the approach to look at hybrid HCI designs, where we take a look at a single tier storage model. And when I say single tier, it's with respects to the video itself or the overall data and where it gets stored. In a single tier model, we target over iSCSI the traditional SAN in the back end that you see for Deep Store Lite and Deep Store. On the actual hyper-converged infrastructure itself, we still build out the HCI. We still build out the cluster. The difference is we only store the virtual machine and we store the database that requires high performance in the HCI cluster. If you look at it from a perspective of operation and why people love the concept of HCI, it's very simple. People love HCI because of the VM mobility aspect. At 2:30 in the morning or 3 in the morning, if a node fails, that virtual machine will migrate, reboot itself, come back online, and start recording automatically. They love the fact that it's unattended. The second feature they like is the fact that they have access to all of their previous archived data. Unlike using a failover mechanism where you simply shift your cameras to record to a different physical machine, because it shares that across the cluster or the vSAN, you have access to all of that data in a pure HCI environment. So your data becomes retained even though the compute part of the model has moved to a different physical machine. So we looked at this approach and we said, can we accomplish the same thing using traditional storage? And the answer is yes. If the VMs and the critical databases for the archivers and the databases that run the VMS reside within the hyperconverged vSAN cluster, then all of those maintain their VM mobility. And by leveraging traditional SAN structure in the back over iSCSI or fiber channel, we can actually target that storage through resilient network paths down to traditional storage, and we maintain the same thing. When we came together with the design, we had a bunch of people in the room. I think there were 4 or 5, and all of us have been in the industry for a long time. And one of the questions that came up is, when is the last time you've seen a SAN fail? And the answer was, none of us have seen a complete SAN failure. So we know that we're going to maintain our data on the back end. We know we're going to maintain our VM mobility, but we do it through a hybrid approach as opposed to a costly all SSD or flash HCI approach for storing the data. If you do require that second tier or that second level of confidence, you can do Deep Store Plus, which will add a secondary SAN in the back end and redundantly record to both. That would be the ultimate, in my consideration, it would be the ultimate level of redundancy. You built redundancy for the VMs and the databases up in the vSAN level. You built redundancy down in the SAN level by targeting redundant SANs with the actual recording data. Now we're going to take a look at the architecture itself. To the right, you see the architecture of the ESXi VMware cluster that is built out in the Fresno office. I didn't include all of the VMs. I currently have 10 to 12 at any given time. In this particular diagram, I showed archivers that are running a total of 8. currently running on the R640 model that we run from Dell. And then you'll see that you've got two sets of pairs of 10 gig NICs. You're going to have one that's used to maintain the cluster and all the required resources in the back end for both the vSAN operation, the overall cluster operation, and communication with the vCenter components. And to the right, you're going to see the redundant paths that go out to the storage. And everything in here has been built with dynamic resource scheduling and high availability, meaning that you have VM mobility of all the VMs can migrate at any given time to the next node that has the lowest level of resources. And you have high availability down to the network infrastructure. On the back of the ESXi boxes, there's LACP, Link Aggregation Control Protocol, redundant 10 gig links that run in an active fashion that connect into the Alcatel-Lucent 6900X20s that we're using. And then on the back end, you have redundant links coming out of the 6900s going over to the target SANs with dual controllers on each one of the SANs. And this particular architecture, it's actually showing the Deep Store Plus or the redundant archiving going across the dual SAN storage over iSCSI. So with respects to load balancing and link aggregation, things haven't changed much in the market since my time at Pelco. A lot of VMS vendors will discourage you from using what I call LACP or active-active connectivity. And there's a reason why they do that. They typically discourage the active-active connectivity because there's a level of expertise on the networking side that's required to configure that to make it work. And when it's not configured properly, it will always drive problematic issues into the VMS platform itself. The reason why we chose the Alcatel-Lucent platform is based upon the automated virtual chassis, the automated link aggregation, and the automated fabric that's built into it. That in conjunction with the BCD video application that we've developed, when this product is being prepared to deployed, you actually simply take the two 10 gig core switches, power them on, interconnect them, wait for the two blue lights to come on, connect the application to the primary, go into your BC Video Assistant and choose the REVOLV template, and the core virtual chassis is automatically configured for you. One of the unique things that they have in this switch is the ability to dynamically and automatically configure Link Aggregation Control Protocol, or LACP. So when you configure on the server side Link Aggregation Control Protocol, it automatically detects it on the virtual chassis and makes the appropriate configuration changes.
Darren?
Yeah.
We have a question. Would you like to take it?
I'm sorry. Sure.
The questioner has asked or stated, essentially, you are saying that you have redundancy and auto changeover for all VMs and SANs.
So I wouldn't say auto changeover on the SAN. When you build a cluster with a vSAN in the back end that houses your VMware file structure and houses your databases and your VMs and the operating system, if at any given time you lose that node, it will automatically vMotion or move to the next node that has the lowest utilization on it. So the answer to that is yes, the VMs will automatically migrate. For instance, if ESXi 2 were to fail right now in this diagram, you can see I have Virtual Machine Archiver 3 and 4. What would happen is Virtual Machine Archiver 3 and 4 on failure would migrate either to ESXi 1, 3, or 4, but it would distribute those VMs across the cluster evenly. So on that side, you have automated recovery that happens between 1.5 minutes to 1 minute and 40 seconds. It moves the VM, reboots the VM, restarts the application or the archiver, and everything returns to its original functioning state. On the back end, if you have a single iSCSI SAN, it's simply going to retarget that SAN from its new location. If you have redundant SANs, it'll retarget both SANs from that location. So you're not really moving anything on the SAN back end. You're simply moving your compute side in the vSAN cluster and then targeting the same iSCSI target on the back end.
Very good. And anyone else having questions, please take advantage of the Q&A section. And to anonymous attendee, thank you. And if there's any follow-up, please feel free to punch it in and we will get to it forthwith. Darren, continue. Thank you and sorry.
Thank you. So the reason behind that was we can automate the actual network configuration. And when you get the network configuration right the first time, there's no room for human interaction or human error or misconfiguration. And so we simply automate that process to make it as simple as possible and provide a diagram for connectivity once it's automated. Everything in the virtual, physical, and network appliance have gone through a full optimization, from the buffers that reside in the virtual NICs to the buffers in the physical NICs to the services that run in the virtual machines themselves with respect to the networking, and the network attributes that are associated with the physical network. We've optimized the buffers and the configuration on the network switches. We've optimized where spanning trees should run, what should be defined as edge ports if applicable. And all of those things come into play in delivering the highest performance possible. And the final note, just discuss the redundant archiving options that we have in the SAN, meaning that you have the option to do 1 or 2 SANs, but keep in mind, in this diagram, I'm actually only showing us using 4 ports off the controllers. We are spacing those 4 ports on the SCSI or on the SAN controllers across controller 1 and controller 2. I didn't use 8 ports or all 8 ports because there really gets to a point where you create an over redundancy or an over resilience, and there simply wasn't a need for it in this design. But those links actually split both controllers on the back of the actual SAN itself. And if you got to a larger system, obviously you could utilize all 16 ports across the controllers if necessary. So this is just a kind of a blow-up model or a view of that with respect to how everything's laid out, where our 10 gigabit connectivity is. I should note that everything's running on the VMware side on separate distributed vSwitches. We have distributed vSwitches set for the VMware communication side, for vMotion, for fault monitoring, and critical services that go between the actual ESXi boxes themselves. And then we've done a distributed vSwitch that spans across the nodes that's completely dedicated to the actual SAN side storage traffic. And those not only both run in their own subnet infrastructure, but they run on their own dedicated VLANs that are configured on the back end for traffic isolation on the redundant 10 gig cores. All right. On that, I'm going to go in and real quickly here, I'm just going to launch a quick demonstration for you guys.
Yeah, and while you're getting that set up, again, let me just throw out, anyone have any questions or comments you'd like to put up into the Q&A, please, while Darren brings this up. What he is about to do now will be effectively the last part of the presentation. At that point, we will be opening it up for nothing but questions and answers. So either one is okay. Darren, back to you.
Okay, and Scott, you can see my screen okay?
Yes, sir.
Okay, so this is the basic layout of what we've got running in vCenter. Obviously, I've got some expiring demo licenses in 21 days that I need to take care of. But in this particular instance, we can see that we have 4 nodes dedicated across, at the time, we called it EVOLV. It's now REVOLV is the product name. But you've got 4 nodes that comprise the cluster, each on the Dell R640 platform. And then as you go through each one of these nodes, in this location here, you can actually see what node it's running on. So it does a very even distribution through, in this case, the 12 nodes that are actually, or the 12 VMs running across this. Obviously, we're running Genetec testing right now with Genetec directory servers, and then we have a vCenter server running here as well. And we have some of them actually powered off for reasons. I think we have 10 running at this point. But if I look at this, right now, Archiver 1 is currently running 6.97, so it's running on this particular node here with respect to its operation, and then you've got your 2 distributed vSwitches that are actually shown in there. What I'm going to do is just do a quick demonstration. Right now, if I log into Archiver 1, you can see the bitrate we have coming in. It's still under an active test with Genetec. Each VM is 254 to 255 megabits per second. The secondary dedicated SAN that's going out to the redundant SAN will oscillate between 6 to 7 to 800 megabits per second bit rate split between the 2 SANs. So you have one side for the data coming into the virtual machines and one side actually going out, recording to long-term storage. You can see, as I talked about in my presentation, CPU utilization is not heavy here. There are a lot of CPU resources that are not being typically effectively used, which is a great reason to look at an HCI type of deployment to begin with. 51% memory, 28% CPU. So in this case, this particular VM is actually running on node 6.97. What I'm going to do is just migrate it. Maybe I needed to do a maintenance of a particular machine, or maybe I needed to do simulate a failure of a machine. I'm going to change the compute only, as the storage will stay where it's at. I'm going to move it to 6.94, select the target and schedule it with high priority, and you will actually see I'm currently migrating that machine in the background. Currently at 41, 43%. If you were to unplug any of these nodes, all of this would happen automatically for the VMs that were there. It would be a little bit extended out in its time frame. As you can see, it completed. It moved to 94. It'd be extended out in its time frame because it has to wait to ensure the actual ESXi box is no longer there. But in either case, you can see that I can launch right back into that machine, and with a small dip in bit rate, you can see it effectively transferred over. You can actually see where it actually dropped its data for that time frame that it took to migrate, and where it picked it right back up running on a new physical machine.
Darren, this would be effectively the same process were the particular node to be have power pulled, becoming stripped on the cable.
Correct. What you would see is if we actually did this where we pulled the power when we came in, there would be an additional overhead. What I see in general is I see that it takes about 1:40 to 1:50 seconds if the power is pulled for it to actually determine whether or not that box is completely gone, and also determine whether or not what particular box it should move it to and complete the vMotion. But any virtual machines running on that would automatically execute its vMotion on node failure.
Yep. Now, let me turn your attention, if I may, back to a question that came in a few minutes ago.
Yeah.
Would you talk a little bit more about the difference between HCI or HCI, as our questioner wants to know why this isn't just a 3-tiered system versus HCI. And then I think he wants a little more of an explanation between REVOLV, or a contrast, I should say, between REVOLV and a 3-tiered system.
Well, so first of all, not all VMS platforms support 3 tiers. They don't. For instance, Genetec is a 1-tier recording model where it's going to record to its primary tier. There are things like Milestone out there that will do 2-tier archiving, where you can record to local live drives and then offset that out to SAN storage or NAS storage or whatever you're using. But with respects to hyperconvergence itself, the difference is how it actually processes the data. So in the example I showed you, the operating systems, the software for the VMS, in this case Genetec, and the database that runs that archiver is the only components that reside in the SSD tier or the pure HCI cluster tier across the vSAN. So if I were to actually store my data, I couldn't run this on an R640 platform. I would have to look at like a 740 XD and load it with all SSD drives to maintain the performance. Because in a pure HCI, you're not only running your operating system and running your database, but you're storing your data there as well. And to accomplish that and attempt to keep the cost down, more often than not, they'll create a second tier within the actual storage of the HCI cluster. So they'll put a first tier of SSD solid state cache drives, and then they'll put rotational drives behind it. Out of the four VMS platforms I've tested today, when the failure occurs with rotational drives on the back end, you get an unacceptable data loss in most cases as you approach the higher level of bit rate going through the box. So you're forced to do all SSD or all solid state throughout both tiers to achieve that rate. The cost of that is dramatically higher when you start thinking about how many nodes you'd have to have in that cluster and how many SSD drives you'd have to use to get a petabyte of storage, versus only running the operating system, the VMS, and the database on the high performance vSAN to get the vMotion capabilities, and relying on a single or secondary SAN in the back end for your long-term storage. You achieve the same goal, but you do it at a much reduced cost.
Okay. So before we move to the next question, for our questioners, thank you. These are all great questions coming in. If you don't feel like you've had it fully answered, please please let me know so that we can get back to it. Before we go to our next question, Darren, 1 quick minute, just in the event we have people who are not necessarily familiar, can you kind of explain the whole concept of a 3-tiered architecture?
Well, I mean, a 3-tiered architecture could have primary SSD storage, rotational, and it could have a SAN for offload in the backend. There are multiple ways to really look at a 3-tier architecture, but in essence, you're putting the data in and filtering it down through 3 tiers for your actual storage. The bottom one being your long-time archival tier. The main difference here is we're not doing that with REVOLV. The archival tier at the bottom is our primary tier for storage. That's where we're pushing all of the data primarily.
Got it. So let's move on. Our next question. When the archiver IP changes, this is when you migrated the VM, how does the Genetec directory know the new IP of the archiver?
It's not changing the IP of the archiver. The IP of the archiver is virtual and stays the same. So in VMware, there's a flat file structure that defines everything. It's basically like when you look at Windows, there's a series of files in a particular structure that represent that virtual machine. That all moves over to the second ESXi host that it goes to. The IP that you're showing it moved to when it went from 6.97 to 6.94 is the host that it's running on, not the IP for the VM. That IP will not change.
Very good. Our next question. As an integrator, if we do not traditionally use VMware, how difficult will it be to take on this product to install and maintain? Does BCD offer training to get up to speed?
Yes and yes. We offer professional services. We also are going to offer training. But in a nutshell, what we're building into this, and I'm not diving into this in this particular presentation, but when I go and I build a new say test in the lab, I have a series of templates that are built into it, that are built in for optimizing archival roles, for Milestone, for Genetec, for directory servers, for Milestone directory servers. We have those templates, and those templates are set for optimal performance parameters for that particular product. So with respects to spinning up an actual virtual machine, you're just going to select a template itself and give it an IP address to boot up. You will have to install the software with respects to whatever platform you're working on, but the underlying virtual machine will be completely optimized for it and set for high availability, just like anything I showed here today. With certain vendors, you know, some of the things we talked about in the previous presentation, we're actually looking to move some of these operations directly into the VMS itself. So when you want to spin up a new archiver, you don't necessarily have to go into vCenter. You don't necessarily have to have that particular area of expertise within vCenter.
Right. And to our anonymous attendee, I will add several things. First, feel free to email us at revolve@bcdinc.com and we can connect with you directly. And second is one of the main goals of our product line, of the REVOLV product line, is to see security become IT ready. There's a lot of meaning to that statement, but one of the simpler ones is it's not complicated, and yes, you should be able to maintain it once professional services does the heavy lifting, if you will, of attaching it into an end user's network. The entire idea behind this is built into the Harmonize software, which is a part of REVOLV product line in general. And again, if you didn't spend some time with us last Thursday, the REVOLV product line is effectively your ability to manage and maintain the REVOLV product through your current video management system. This is an ever-growing piece of software that will, you know, at its conclusion, not that software ever has one, will allow you to do almost everything that you're able to do, because some things you have to go into VMware to manage, through the comfort and recognizable GUI of your video management system. So we are not trying to present to you a product that will require you to take, you know, dozens of hours of training to manage and maintain, but rather a product that to you feels a lot like the video management system you currently have in place and that you've installed before. So again, anyone with similar type of questions, please come on and let us know.
And Scott, I would add into that.
Yes.
Just to close out that question, one of the metrics I used to see if we were maintaining the simplicity aspect with the templates that we were building and everything underneath it was I launched into the actual console itself to use the templates, and through about five bullet items on a sheet of paper, I saw if my 11-year-old could spin up a Genentech archiver and get it to the point where it's installing. He absolutely did it, and he did it flawlessly. So it's not difficult. It doesn't require months or years of training. The idea is we're building the automation into it to simplify that aspect.
Very good. So we have another question which has come in that you and I can both address. Which one is more cost effective, traditional HCI or hybrid HCI? So Darren, you take the first swing, and if necessary, I'll drive you home.
Hands down, it's going to be hybrid HCI. You look at the cost comparative of taking and building out a large scale mass amount of storage within an HCI cluster itself, whether you're using whether you could get away with using a caching tier and rotational tier, or you had to use an all caching tier, which is more likely. It is going to be more expensive to do that than it is to put your primary storage in the back end for a SAM.
And let me add to that this. Let us pretend, for the sake of this question, that the initial installation side by side is exactly the same to the penny. Then you have to add storage for, you've changed retention. You've gone from 6 months to 9 months. Your traditional HCI is going to require you to purchase an entire new cluster of compute and storage, whereas our HCI system simply allows you to buy the storage. So not only do you have a cost savings, but as Darren has mentioned on multiple occasions this morning, you also have a compute savings. You're simply not spending money on resources that will not be used. So to summarize, even if everything costs exactly the same at the beginning, the second you have to grow it, HCI is going to be less expensive.
Absolutely. And the fact that you can run multiple virtual machines that are less resource intensive. You could deploy your access control system on here and give it high availability operation.
The word, Darren, you died at the word merge, I think is where you were going. Can you repeat?
So it gives you the ability to merge other platforms in there that are not resource intensive. Access control systems, fire and alarm suppression, you pick it. Whatever you have and may not have high availability built into it today on the back end for those servers, you can give it high availability functionality. They're not terribly resource intensive. When you start looking at today's market, we're using separate independent servers for those functions, and you collapse those or converge those into this model, you're going to save a ton of money.
I hope that over the last week of webinars and outbound information that we here at BCD have made it clear that REVOLV and the product line they're in, while an HCI solution, is still possessed of all the benefits on the compute side of the HCI solution. Not only node fail, but also, as Darren just said, if you're running a VMS and an LPR system and an access control system, you can run all of them as long as they can be virtualized. You can run all of them on a REVOLV just as you would with a quote-unquote true HCI system. The fact that we've specialized for what is our industry does not mean that a pure IT department couldn't pop in, buy REVOLV, and use it in exactly the same way they would a true HCI product.
And it's important to point out, Scott, that not all VMS platforms may run in hybrid HCI. So if you take a look at Milestone, it would run in a true HCI deployment. Its primary storage, I would build that out differently than what I have today. I would put more SSD drives in the 640 platforms, perhaps more servers even, if I had to. And I can do my primary tier 1 storage or my live drive storage directly in the HCI cluster at high availability on smaller partitions and still archive that off to the SAN resiliently. That is a true HCI because of the 2-tiered architecture that you have that can be supported within Milestone.
So can you expand just for a moment for the audience on a piece of what you just said, which is not all VMSs can be run in an HCI environment, obviously without naming any names. Let me ask it this way. Why would a VMS not be able to run under HCI? What would
It's not that it can't run under HCI. What I'm saying is that in a Milestone's instance, it would be considered a pure HCI, not a hybrid. because you are recording data or video to your primary SSD caching tier.
Got it.
Okay. The difference is under Pelco, Genetec, different VMS platforms, they don't record to a live drive tier and then offload that to a SAN in the back end or NAS. They're actually going to pick their primary target. For those particular installations, I'm going to record directly to the SAN and leverage the hybrid HCI model. But there are particular instances where I may choose a true HCI approach, and Milestone will be one of them.
Okay. Very good. Thank you. Another question from the crowd, which I will answer simply. When under HCI, and you have to add another cluster with additional compute and storage costs, are there additional costs for VMware and other software? The answer is yes. The way that VMware and the way that BCD is licensing VMware is based on what amounts to a per node price. So as you add compute clusters, there are additional licensing costs, which are effectively determined by what you're doing, how many cores are in the node. It gets kind of confusing. One important point, we do not, and let me underline the word do not words, require you to buy these licenses if in fact they're already possessed by the end user. There are plenty of examples of this. Large corporations, governments, nonprofits, etc., who may have a giant VMware corporate package. Great, we are happy to use those licenses. So if you buy an initial thing from BCD and you add more and you happen to realize you have a corporate license, great, we are happy to use those licenses. So another question that just popped in, I believe.
Hold on, Scott. Before we go to,
sorry, go ahead.
I want to touch back on that one because that is probably not the way I would approach that. If I'm looking at a 4-box HCI cluster today, and what I've got 4 boxes like I'm showing you today, and I've got a SAN on the back end, and I haven't reached the max expansion storage capacity, which can go somewhere between 3 to 5 petabytes in some cases. If I can add storage expansion on the back end of that, I can simply add 4 more nodes to the existing cluster and then upgrade my licensing to literally accommodate the new CPUs that are coming into it. You don't have to spin up an entire new cluster, and I probably wouldn't. There's no reason to.
Fair enough. That's why we have Darren on the call, ladies and gentlemen, is because he can correct me when I am not quite there. So let's address this next follow-up question. Is it possible that we will be providing some tabular comparisons for both traditional HCI and HHCI? And the answer is yes, we will be. We will have all manner of tools, both public-facing and inward-facing, to help us do comparisons on HCI, HHCI. We will have comparisons that allow you to look at costs associated with not only using a standard BCD server set, meaning just storage and disks without the HCI component, but we will also provide you comparisons on buying the hardware necessary under the standard server and disk configuration, but purchasing hardware that will allow you to upgrade into our hybrid HCI system, having already purchased the hardware. So there will be all kinds of different ways for us to look, because any end user, any customer that we have out there who is not perhaps ready to take the full jump can certainly prepare by purchasing the correct hardware for an upgrade down the road. So there's your answer. We will have all kinds of tools available.
And Scott, I think it's important to really, really talk about at its conception, when we put this product together, it's been a big philosophy of mine for years, is to get away from speeds and feeds. Everybody wants to look at what specification is, what the server is, what the port speeds are, what its CPUs are. What we looked at is, what do people like about HCI? Why do people buy HCI today? And what don't they like about HCI? So we put it all up on a board and we started architecting this out and said, these are the components, these are the reasons people buy HCI. The model we developed had to hit all of those bullet points, meaning it delivered the exact same thing, but delivered granular or modular upgrade capabilities at a reduced cost. You didn't have to update compute and storage at the same time if you didn't need to. You could add an expansion box on the bottom of the SAN at a reduced cost and leverage the same controllers and expand your storage out. And if you needed to do it, then you could put another expansion box below it. But you're not buying 6 to 8 more servers to get that particular storage. when you're already underutilizing your CPU and memory resources already. That's the Achilles heel of HCI, in my opinion.
Very, very interesting. So as I look back towards my Q&A, I see it blank and sadly empty, but hopefully that means that we've answered everyone's questions. I will ask that anyone that does have any additional questions, if you don't feel like bringing them up here in a public forum, please feel free to contact us. The email is revolve@bcdinc.com, and thankfully we remembered to put our Revolve phone number, which you can see here at the bottom of the slide, 833-REVOLVE-1. Feel free to come in. I am happy to say that we have been quite busy putting things together on the Revolve platform. So at this point, we've done quite a bit of configuration work, and I'm confident we can answer any questions that may come up or needs that may come up. Darren, would you like to have anything in closing?
Just in closing, I really want to thank everybody for taking the time to attend the technical dive into this. You're more than welcome to contact me directly. My contact information here is on the screen with respects to email. If it's more critical, you can give me a call. But just really thank everybody for attending, and send a special thank you out to the VMware and Dell team, which really helped us bring this solution together. There were a lot of resources out there that really backed us up as we hit roadblocks and figured out how we're going to do things. And I truly believe that we've built a very cost competitive and efficient competitive model to HCI that gives you a better level of granular access to your upgrade path.
Thank you, Darren. From me, nothing more than a simple thank you for attending. Thank you for everyone that could make it. If you have colleagues that were unable to attend, please let them know that we will provide a link for the recording. And keep an eye on our website, as the format you've seen today will be a big part of our Revolution University series. We kicked it off last week with Larry Newman, and it will be continued here in the upcoming weeks with new guests and additional information coming from our industry. So my shout out, as always, would be to Amanda Potos and the marketing team for doing such a great job helping us look competent. And with that, we will say thank you, everyone. Enjoy your long weekend and stay healthy.